Okay, ladies and gentlemen, this video is actually going to cover two proofs. I said in the previous video it was going to cover three, but we're going to go a little bit slow through the first two proofs and make sure that we have a good solid understanding of what's going on. And then the next video will cover three additional proof examples, and it will go a little bit faster because by then we should have seen some patterns and we should have some things that work out a little bit better for us. So here we're asked to prove the if-then statement that if ray DB bisects angle ADC, then angle 2 is congruent to angle 3. So remember that when you are setting up a proof from an if-then statement, your hypothesis is your given and your conclusion is what you're being asked to prove. Okay? So we're going to go in here and we're going to say, okay, our given is that ray DB bisects angle ADC. And actually, I may change my mind and do three proofs in this video. We'll see how the timing works out. And we're being asked to prove that angle 2 is congruent to angle 3. So every proof, no matter what kind of proof it is, always starts off exactly the same way. And that is that ray DB bisects angle ADC because that is the given. Every proof we do should start with us stating the given information again. Now, every time we've done a proof, we have always started by taking those givens and doing something with them, by turning them into equations or congruent statements or something. So in this case, the fact that angle 1 is congruent to angle 2 is based on the given. But the reason is not super obvious. We need to think to ourselves, why in that picture is angle 1 congruent to angle 2? Well, in the picture, we are told by the given that ray DB, this ray right here, is bisecting angle ADC. Now, the word bisect means cut into two congruent pieces. So the reason for step 2 is that is the definition of the word bisect, bisector. Okay, the definition of bisector. Since DB is an angle bisector of angle ADC, it is dividing that angle into two congruent angles. The next step asks us to find a set of vertical angles in the picture. So if we look at the picture, we have a set of numbered angles, angle 3 and angle 1, that are vertical angles. Now we have to be careful here because I've written this proof to be as short as possible, which means that in this step we have to put angle 3 first in order to complete this proof. Now the reason for that is we have not turned anything into equations, which means that we are not allowed to use the substitution property, but angle congruence is reflexive, symmetric, and transitive, so in step 4 we could use the transitive property. So watch closely, please. Angle 3 is congruent to angle 1. Angle 1 is congruent to angle 2. Therefore, by the transitive property, angle 3 is congruent to angle 2, which is what we have here in step 4. So the reason for that is transitive property. Now remember that that has to perfectly match our pattern for transitive property. It has to say A equals B, B equals, A is congruent to B, B is congruent to C, therefore A is congruent to C. If it doesn't perfectly match that pattern, you can't use the transitive property. So if we had this statement reversed, angle 1 was congruent to angle 3, then we would have had to include a step in between where we flipped it around anyway using the symmetric property, which just is not helpful. We want to keep things as clean and as short as possible. But that does show that there are more than one way to do these proofs. Okay? So the transitive property says that since angle 3 is congruent to angle 1 and angle 1 is congruent to angle 2, that means that angle 3 is congruent to angle 2, which is what we've stated here. Now that is what we're trying to prove, except it is backwards. So we do have a requirement to flip that statement around and state that angle 2 is congruent to angle 3. The property that allows us to do that is our symmetric property. That completes our first angle proof, and we're ready to move on to the next one. Now this next proof is one that looks significantly more familiar to us in terms of pattern, because this proof very closely mirrors the segment addition postulate proofs that we did in the last section. The difference being that we're not dealing with length of segments anymore. We're going to be dealing with angle measures. Okay? So, just like any proof, we start by restating the given, angle ABC is congruent to angle DBC, or DBE, sorry. That's our given. And just like we did in the previous section, since we're going to be trying to use the substitution property, and we're going to be trying to move stuff around and manipulate equations, we have to turn that congruent statement into an equation. Well, with angles, if we have that two angles are congruent, that means that their angle measures must be equal, because that is the definition of the word congruence. So it is still possible to do proofs like the ones we did in the last section with angles. We simply would turn our congruent statements into equality statements. And we have to remember that angles are congruent. Angles are congruent. Angle measures are equal. We can't just say angle ABC is equal to angle DBE, because angles are not equal. Angle measures are equal. Angles themselves are congruent. So, in step 3, we should recognize this style of pattern here. We have a big angle is equal to the sum of two smaller angles. If we look at the picture, angle ABD is made up of angle ABC and angle CBD, which is what we've written here. Angle ABD is equal to ABC plus CBD. Same thing for angle CBE. It is made up of two smaller angles as well. So in step 3, we are using the angle addition postulate, which we added in this section, which states that adjacent angles can be added together to form larger angles. Okay? So that is the angle addition postulate there in step 3. Now be careful on step 4. Step 4 is not a substitution step. If we notice, step 4 is our step 2 equation. ABC, measure of ABC equals the measure of DBE, are still in there, except that they've added the measure of CBD to both sides of the equation. So step 4 is addition property, because we have added the measure of CBD to both sides of statement 2. Okay? Now from there, this becomes a straight up substitution problem. Because if we notice, this angle ABD is equal to the left side ABC plus CBD. And this measure of angle CBE is equal to the right side. See, measure of angle CBD plus the measure of angle DBE is a perfect match. So what we're going to do is we're going to substitute measure of angle ABD in for the left side of our equation, and we're going to substitute CBE in for the right side of our equation. Again, that is a substitution property step. A little bit annoyed with myself for not having the word property written after substitution. And finally, notice that that is what we are trying to prove, except we're trying to prove the angles are congruent. We have stated that the two angles have the same measure. And just like we did in the last section, if the measures are equal, that means that the angles themselves must be congruent, because that is the definition of congruence. That completes the second proof. So we're going to go on, I think in this video, we're going to go ahead and do one more proof in this video, which in theory should give you enough to start the classwork, but there will then be 2 additional proofs in a following video. So let's do a third proof here. Here's our third proof. We are given that ray BA is perpendicular to ray BC, which we see the right angle in the picture indicates that those are perpendicular, and that the measure of angle 1 is equal to 5 times the measure of angle 2. So we start every proof the same way. We restate our givens. So ray BA is perpendicular to ray BC, and the measure of angle 1 equals 5 times the measure of angle 2. That is our given. The fact that BA and BC are perpendicular is our complement theorem. It states that if the non-common sides of adjacent angles form a right angle, which is BA and BC are the non-common sides of angles 1 and 2, that means that angle 1 and 2 must be congruent. Or, I'm sorry, not congruent. Complementary. So we're adding those two together and setting it equal to 90 degrees. That is what the complement theorem says. that if the non-common sides of adjacent angles are perpendicular, or form a right angle, then those two angles must add up to 90 degrees. Now, look at what we're trying to prove. We're trying to prove that the measure of angle 2 equals a number. So at this point, this is basically an algebraic proof for the rest of the way out. Only we currently have two variables in our equation, measure of angle 1, measure of angle 2. We do not want two variables. We can't solve an equation that has two variables in it. So we need to get rid of one of those variables. That's why this next step is the substitution property. Because what we're supposed to do is take 5 times the measure of angle 2 and replace the measure of angle 1 in the equation in step 2. The reason we do that, which would be 5 times the measure of angle 2 plus the measure of angle 2 equals 90, is that now this equation is basically a one variable equation, and we can solve it using our algebra skills. So between step 3 and step 4, you have to think of the measure of angle 2 as being a variable. If that said 5x plus x, everyone in the geometry class could tell me that the next step would involve combining like terms. 5 times the measure of angle 2 plus 1 times the measure of angle 2 is 6 times the measure of angle 2. So step 4 is a substitution simplify step because we are adding like terms. Okay, so right there in that step we are adding like terms. Anytime that we add like terms, that is a simplification step, so we use substitution simplify to do that. Now we are trying to get down to the point where we are stating that the measure of angle 2 is equal to 15 degrees. So what we do is we divide both sides of that equation by 6, which again, that takes 2 steps. First we show it, which is the division property, and then we actually carry out the division, giving us the measure of angle 2 is 15 degrees, because that is substitution simplify. So that does it for our third proof and this video. There will be an additional video showing additional proof examples, but with these 3 examples you should be able to start the classwork. Some of you may not need the third video, okay? But it'll be there. If you get stuck, go watch the other video. It'll give a few more example proofs. Thank you very much for your time.